Today, we're going to be making our own brushless robotic actuators using these frameless motors. This is pretty useful to know if you ever decide to integrate your own motor into your robot. I'll walk you through step by step how to put everything together, so let's get started. I've been doing robotics and AI for 10 plus years and have lots of resources on my channel, so check it out and subscribe for more. And thank you PCBWay for sponsoring this video. So this right here is the frameless motor from CubeMars. So let's take a look at what's inside. So you can see inside of here we have some screws here. So these screws we'll be using later on to secure our housing together, which I'll talk about. And there's also a tiny little pin here, which I'll tell you how to use that in just a little bit. But here you can see this is the frameless motor. This is with all the magnets already secured. And then we have these holes here for mounting, which I'll show you how to mount in a little bit. But the most important part is this part right here. This is with the windings. So these three cables that you see here, these are the UVW, which we'll use to power this brushless motor. And then these cables here are for Hall sensors if you need it for additional sensing. But what's really special about these motors is that typically you would see these magnets on the inside of the winding, but in this case, these magnets are actually on the outside. So we'll take a look at how to actually assemble this and make our own custom actuator. And to actually make these motors, we got some parts custom made from PCBWay. So they're pretty nice. They could do 3D printing and CNC, but you can see everything came shipped nicely wrapped. So you can make sure that nothing gets damaged upon arrival. But let's go ahead and open these and see what's inside. All right, so these are all the parts. We'll explain one by one what each one is. So we'll start off with this one right here. This one is a bushing that I made. So typically with lower speeds, bushings are fine. So that's why I didn't want to buy a bearing for this design. But this is actually made out of Teflon. So it actually is very slippery when it's in contact with other parts. So I made two of these. And then these right here, this is for the encoder magnet, which we'll talk about in a little bit. But the way this works is you're going to have to put the magnet inside of here, and then we'll show you how that works. And then these little white pieces, these are some standoffs, which will space the encoder board from the main housing of the motor. So I had two more pieces here. These are metal pieces that I machined. They're super nice. They look really good. You can see it came out exactly as I expected, but let's see if the fitting is actually what I want it to be. So I actually placed some pretty tight tolerances on these parts. So this bushing is supposed to go right here, and you can see that it fits like a glove. You can see there's very little play. I put a lot of tight tolerances there. And if we see how this part fits too, you can see that it snaps right in. It barely has any play. Like if I move it back and forth, it pretty much doesn't move at all. But later on, you're going to see that one of these parts will fit in something like this. So you can see that it spins very nicely, almost no friction. So it's very good. But once we see everything assembled, you'll see how everything works. So let's go ahead and start assembling this. So we'll start off by attaching this piece onto the part with all the magnets. So the way this is going to be oriented is going to be something like this. And we have these holes here, which you have to mount to. You can see I have some threaded holes here, which I will use to thread that together. So we're going to be using these flathead screws here to secure the two parts together. So let's go ahead and start that. But before I do that, I just want to show you really quick how nice this tolerance is. You can see when I push it, there's almost no play. So the tight tolerances I gave is actually very good, and it fit exactly as I expected. So this is pretty nice. All right, so you can see I put all the screws in now and it secured it pretty nicely. I did notice that the screws came out a little bit on the other side. I thought it was going to be flush, so I probably could have made this plate a little bit thicker, but overall all the parts fit together as I expected. So now let's go ahead and put the next part together. So this next part is going to involve putting this right here. So this part is going to be the one that has one of my bushings here. So this bushing is going to sit down, and then I have another one right here that will go like this. So if you look closely here, I actually have a slight rise above the metal piece for this bushing. So this little bit of rising is going to make sure that the metal is not going to touch the metal directly. But you can see that this piece here is supposed to go inside. I need to put the other part inside later on, but I'm just going to show you how it fits. But you can see how nicely this spins with the bushing. So this is really nice. And this other part is supposed to go right here, and that's why it makes it fully supported. So this is how the motor will actually be operating. But one thing to note is that I did notice that this bushing that I made is a little bit loose, so it falls right out. So that part is not as tight of a tolerance. I'm not sure what happened there, but at least this one you can see when I flip it over, it doesn't fall out. So that part is good at least. Okay, now let's go ahead and install the motor winding onto this part here. So these slots that I made here, this is to pass the cables through. So let's go ahead and pass that through and put it on together. All right, so you can see I passed the cables through and everything fit nicely as expected. One thing you're going to notice, what I skipped is typically there should be some glue between these two parts, but because I don't plan to keep this and I want to reuse this for later, so I didn't actually want to glue it. But let's go ahead and show you how you can actually use the pin. So when you get these frameless motors, they have this tiny pin that comes with it. So this pin is supposed to go inside of this hole here. So when you put this pin inside, it helps it secure a little bit better in addition with the glue. So it's kind of like a keyway just in case something slips. So it's just mostly for additional redundancy to make sure that everything is nice and secure, especially if there's a high load, then that would be pretty helpful. And you can see right here, I added 3 M3 screws here that will secure the two parts together, so everything is nice and secure. Okay, so now that I have that part together, what you want to do is take this part and then put it in through here where I have my bushing. So you can see that it's going to insert right through here. And I felt the magnet kind of slip, or not slip, but you could feel the magnet attract each other. And then I'm going to put this bushing back in here because that part kept falling out. And what I want to do here is typically you will want to have a much better retaining ring, but I just printed one really quick for the sake of demonstration. But in practice, you want a much stronger retaining ring, probably in metal, or if it's plastic, something much bigger so that it can actually hold everything together. But overall, you can see that this spins very nicely. I'm surprised how well the Teflon bearings worked. So if you want to have any low speed applications, I would say this is a pretty good option. And the last part is you could take this and put a magnet here. So I had videos on how to actually use O drives, but you could use the O drive micro with this assembly here and insert it. If it's a little bit loose, you could add some glue or some sort of tape around this to actually make it secure. But once you do, you could put this in together, and then this will have the magnet which will read from the encoder. So these standoffs here that you could space the board from the magnet, you could actually use this for the mounting. I have a bunch of videos on how to do that in my other O-Drive videos, but because I didn't actually glue everything together as you're supposed to, because I may repurpose this, I don't actually want to run it. But if you do want to run it, you could integrate a O-Drive with this as I show in my previous videos.